Let's see about the refraction by a lens. Considering the refraction by a lens, it is worth mentioning that the two foci, which is nothing but f and f dash. So you can find here f over here and f dash over here, which are considered to be the foci. So these two are considered to be foci of the double convex or else concave lens which are at equidistance from the optical center. The focus on the side of the source of light is called the first focal point, whereas the other is called as second focal point. So you can find here how the convex lens is having its focal point over here, and this one is the consideration which we have been mentioned for tracing the rays through the convex lens. So you can see how the convex lens is implemented over here. So in order to find the image of an object by a lens, we can in principle take any two rays emanating from a point on an object. So trace their paths using the laws of refraction and find the point where the refracted rays meet. That is nothing to be appear or to be meet up. In practice, however, it is considered to be convenient to choose any two of the following rays. So that's nothing but a ray emanating from a point, that is this one. So a ray emanating from the object parallel to the principal axis of the lens after refraction passes through the second principal focus, which is indicated by f dash in a convex lens, or appears to diverge in terms of a concave lens from the first principal focus indicated as f. A ray of light passing through the optical center of the lens emerges without any deviation after refraction. So you can see here how the ray of light passing through the optical center of the lens, this one is the optical center, and it is going to be emerged after refraction. A ray of light passing through the first principal focus or appearing to meet at it emerges parallel to the principal axis after refraction. So you can find here this has been depicted over here. Here you can see the illustration, and you can also find the rules for a convex and concave lens respectively. The thing which we need to have in mind is that whenever we have a practice by applying this conceptual logic test, then the ray diagrams for different positions of the object with respect to the lens also tends to be verified that the lens formula which has been given holds good for the cases. That is indicated as 1 by V divided by 1 minus U is equal to 1 by F. Here again it must be remembered that each point on an object gives out infinite number of rays. So all these rays will pass through the same image point after refraction at the lens. So the magnification which is indicated as m produced by the lens is defined like that for a mirror as a ratio of the size of the image to that of the object. Proceeding in the same way as for spherical mirrors, it is easily seen that for a lens we have m equal to h dash divided by h, that is equal to v by u. When we apply the sign of convention, we see that for erect image formed by a convex or concave lens, m is positive. M is indicated as magnification. While for an inverted image, m will be negative. That is, the magnification will be having its negative impact.